Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Waalaikumsalam Fir. Good morning Mac. Good morning Pei Chong. Good morning Junlong. Waalaikumsalam Najwa. Waalaikumsalam Mai. Waalaikumsalam Sam. Waalaikumsalam Firzan. Salam Umi. How are you guys? Okay, so I hope you're good and you have had your breakfast. Okay, so to begin the day with, okay, because breakfast is very important to fill up your day, and I hope you guys are also prepared, okay, to start fasting tomorrow. Okay, so we are now in week 12, so that means we have, including this week, we have about 3 weeks left. Okay, and I do think that we still have time, so there's no rush, okay, to finish topic 10. And so that's why I decided to discuss some of the past year questions with you on topic 9, okay, so that you'll be able to understand topic 9 very well. And in fact, because mark allocation for this topic is quite big, it's about 1/3 of the total marks, so you just need to pay most attention to this topic. Okay, this is very important. Okay, if you want to get A for maths, so this is the topic that, okay, you need to pay attention to. Yeah. Okay, so I'm going to discuss some of the past year questions in the book, okay, involving continuous random variable. And then if we do have time, so I will discuss past year questions in recent years. Okay. Salam Razik. Okay, morning Farah. Waalaikumsalam Aisyah. Good morning Arvind. Good morning Nob. Morning Zahid. Waalaikumsalam Kai. Okay, so now let's begin the discussion. Okay, and again, if you have any question, so you can just ask in the live chat now. Okay. And yeah, because we're going to miss some of the tutorial classes, right? Okay, so so that's why I decided to discuss the past year questions in lecture so that we can compensate the hours. Alright, and I will let you watch the lecture videos on topic 10, okay, during the missing hours, okay, during the holidays, the 2 days holiday this week. Okay, morning Amira. Okay, so now let's see, so for today's discussion, so I have chosen past year question number 2. So if you do have your tutorial book with you, okay, so you can just refer this question. Before that, okay, so let us summarize topic 9. Okay, so topic 9 is all about discrete random variable and continuous random variable. So we do have these two types of random variables, and you have to know how to differentiate between these two, okay, in order to tackle the question well, okay, because once you decide the type of random variable, then it will help you with the formula needs to be applied, okay. So discrete random variable is when you have countable numbers, and for continuous, okay, it's when you can express within intervals, okay. And then when we talk about the PDF, so the PDF is probability distribution function for discrete, and for continuous it's called as probability density function, and this is the notation of PDF for discrete, and this is notation of PDF for continuous. Okay, and then how to show that, okay, the random variable is discrete is by finding the sum and show the total is 1. And okay, for continuous random variable, in order to show that it is continuous, so you just need to show that the total area below the graph is 1. So in order to find total area, so it's about finding the value of the integral, okay, so you just need to show that the integral is equal to 1. Okay, and then when we talk about the cumulative distribution function or cumulative density function, so for discrete, you just need to total up. Okay, you just need to find the sum. Alright, while for continuous random variable, in order to find the cumulative density function, it's about finding the cumulative area, okay, or cumulative probability. So cumulative area is just by integrating. So you can see here, in order to transform from PDF to CDF, okay, we just need to add, and the opposite way is just to subtract. So this is for discrete. While for continuous, okay, from PDF to CDF, we just need to integrate, and the opposite way, if you need to convert CDF to PDF, we just need to differentiate the CDF. Okay, and then when it comes to the median, so it's the cumulative probability 0.5. And when we talk about discrete, it's about the sum of probabilities, yeah. And when we talk about continuous, it's actually the sum of area, which means the cumulative probability using the integral. Okay, and same thing applied to quartile, percentile. Okay, and for mode, if you need to find mode for discrete, you just refer the table and you find x with highest probability. Okay, while for continuous, okay, in order to find the mode, so by hook or by crook, you need to sketch the PDF graph and then look for the highest peak. Okay, so you find the highest peak and you find the value of x, which has the highest peak, and then that will be your mode. Okay, then how to find expectation or the mean? So in order to find mean for discrete, so it's all about using the formula here, sum of x multiplied by its PDF, while expectation for continuous is about the integral of x multiplied by its PDF. Okay, then the formula of variance is applicable for both discrete and continuous, where you have expectation of x squared minus expectation of x squared. Okay, while standard deviation is simply square root of variance x. And the properties also will be applied for both continuous and discrete. Yeah. Okay, properties of expectation here is also applicable for both discrete and continuous. Properties of variance here also applicable to both discrete and continuous random variables. Okay, so now let's begin our discussion. Okay, so this one I've got this question. Okay, pass your question number 2. Okay, so we do have this question. So the question says, the continuous random variable x has the probability density function of this, where fx is given. Okay, so now we are given the PDF of continuous random variable x. Okay, so this is the PDF. Okay, and as I told you, okay, whenever you come across any question on topic 9, first thing first, you identify whether the variable is discrete or continuous. Okay, if the variable is discrete, so make sure you construct table, because that will help you a lot. If you have continuous, so my advice is you draw a number line. Okay, you draw a number line and then you just label the respective functions, define, yeah, okay, with the respective range. Okay, so now we are given this function. Okay, the PDF is given here in piecewise function. Okay, where you can see that this is the symbol of absolute, yeah. Okay, and then the question says show that the A is 3 set 2 over 4, and this is the A. And before we start finding the value of A or start showing that A is this value, you need to use the absolute, because in back in semester 1, topic 1, when it involves integration, there's no such thing as integral of absolute. We didn't discuss this one. Okay, so we cannot find the integral of absolute function. So in order to integrate this particular function, we need to use the definition first. Okay, so we are going to use definition of absolute, because here you can see that there is absolute of x here. Okay, so this is absolute of x. So we are going to find the definition first. So using the definition of absolute, so absolute of x is defined as positive when x is greater equal 0, and absolute of x is defined as negative x when x is less than 0. Okay, so now you can see that at first, the function here is defined from -1 to 1. Okay, so this is the region from -1 to 1. Okay, but because we do have absolute of x, so then the absolute of x is defined as this. We're going to take the positive when x is greater equal 0, and we're going to take the negative of x when x is less than 0. So what do? We're going to split into two different regions here. Okay, so when x is greater than 0, but in order to, for this region, even though it's x greater than 0 here, but then it doesn't mean that it's going to be until infinity. Why? Because the function is only defined up to this point. So that means when x is greater than 0, we will stop at x equal 1. So this is the region. Okay, x greater than 0, we will stop at 1. And not only that, for the second, okay, for this one, okay, you can see that the definition of absolute, okay, the x will take negative sign when x is less than 0, but it won't be until negative infinity because, okay, the function is only defined until negative 1. So that's why here we stop until negative 1, yeah. Okay, we stop until negative 1. So it will be negative 1, okay, x greater than, so then we will have until 0 only. Okay, so for x less than 0, greater equal negative 1, we just take the negative sign of x, while for x positive or greater equal 0, we take the positive of x, and then, okay, from here you can see that what is going to happen is this will become 0 because we have minus x plus x. So which means, okay, this function is going to be combined with this function 0, and it will be in the region otherwise. Okay, so we will only have one particular function, okay, which is this one, okay, which is this one, and we just bring it down. So you will have x plus x, which is 2x, and then we will have a times 2x, and then for this region we just copy down. Okay, so now, okay, the function has been simplified. So this is the final function of, okay, continuous random variable x. Yeah, so this is the final PDF. So this is the PDF of x. Okay, now after we have simplified the PDF, only then we can find the value of a. Okay, so how to find the value of a? We use the concept of total area. Okay, so for continuous random variable, so we just need to show that this is total area. Okay, so total area under the PDF graph. So this is total area. Okay, under the PDF. Okay, under the PDF function. Okay, is equal to 1, or okay, we can also say that it's about total probabilities, right? Okay, so the total probabilities is 1. So because this is continuous, it's about finding area, so we're going to use the integral. And because there's only one function defined, so we can see that this function, okay, this PDF is defined from 0 to 1 only. So if you draw a number line, so this is 0, this is 1, so the PDF here is defined from 0 to 1. Okay, so this one is 10 circle, this one is empty circle. So we have this function. So when we talk about total area, so the total area below this graph is going to be 1. So we just integrate from 0 to 1. Okay, the function here 2x power of half. Why 2x power of half? Because it's actually set of 2x. So set of 2x is 2x power of half. Okay, and then we just equate to 1 because again, its total area. Okay, the total area must be 1 because we are dealing with probabilities, right? So, and we discussed before, total of probabilities is 1. Okay, so now what do? We just integrate the function. So how do we get this? Okay, how do we get this? Okay, by using the rule of integration. So this, but okay, let's recall the rule. Okay, so the rule of integration in topic 1. So rule of integration that I apply here is this formula. Okay, where you have the integral of ax plus b power of n. Okay, so when you integrate this function, okay, as long as the function in the bracket is in linear, so you're going to get the result as ax plus b to the power of n plus 1 divided by n plus 1. And then don't forget to differentiate the function inside. So you can see that the derivative of the function inside is a. So that is how we obtain the integral. So integrating to x power half will give us 2x power 3 over 2, and then divided by 3 over 2, which is multiplied by 2 over 3. And then don't forget to differentiate the function inside, so you will get 2 here. And then by cancelling this one out, so you will have, okay, and then you bring the 1 over 3 out here. Okay, so then substitute limits. So we will have this 2 set 2a over 3 is 1. And then, okay, by bringing 3 to the right, we're going to multiply by 3. And then 2 set 2, we bring it down here. So we will have 3 over 2 set 2. And because this is proving question and the answer has to be exactly, okay, the answer has to be exactly the same as the one given in the question. Okay, so now we just multiply this by the conjugate. Yeah, so this is the process of multiply by the conjugate, or this is the process of rationalizing fraction. Okay, because the set cannot be in the denominator, right? Okay, so now you multiply both numerator and denominator by set 2, so you will obtain the value of a to be 3 set 2 over 4. and you write down here shown, yeah. Okay, and because this is proving question, so again this is like a bonus for you because the answer is already there. You just need to make sure you get the answer as given in the question. So now done with the proving question. So okay, we have got the A, so we substitute back the A, okay, because the question just the function given is, okay, because the function here is A times set 2x, right? Okay, so now because the A is 3 set 2, so 3 set 2 over 4, and then you multiply by set 2x. And by using indices law, so okay, so this one we bring down 3 set 2 over 4. So set 2x can be, okay, split into set 2 times set x, right? Okay, we apply the indices law. So now set 2 times set 2 will give us 2. So you will have 3 times 2 will be 6. So 6 over 4 set x. And then lastly, you can simplify the function to be 3 over 2 set x. So that's why you can see here the function of x being, okay, being simplified to 3 over 2 set x. Okay, so now we have got the function here, the PDF, okay, with the value of A known. All right, so after we get the value of A, so we substitute back into the PDF, and then okay, it's time to solve the rest of the question. Okay, so now the question says find the probability of X greater than 0 and less than half. Okay, and because we know that, all right, 0 and half, so half is in between, right? So this is where the half is located, which is 0.5. So we know that, okay, we need to find the probability, okay, between 0 and 0.5. So we can just integrate, yeah, okay, because we only have the PDF. Okay, so we just integrate. The question says find probability of x greater than 0, less than half. So it's about finding the area, okay, finding the area below the graph, okay, from 0 to half. Okay, so now what do we do? Okay, we bring down the PDF. Okay, so this is actually the formula is going to be this one. Okay, so we, okay, it's about finding the area. So we just need to integrate the function of PDF. Okay, so you just integrate from 0 to 0.5, from 0 here to 0.5, and we just bring down the PDF. Okay, so this is what we get. And then integrating the function, so then substituting limit, you will get this value. Okay, but then because the question asks for, okay, the probability in set form, right? Okay, so if you refer the question once again, okay, the question says find the probability and give your answer in set form. So again, make sure the answer has to be in exact form, yeah. Okay, so but then we cannot simply leave this as the answer, 1 over 2 set 2, because it has to be rationalized first. Okay, so the process of rationalizing the fraction, okay, is just multiplying both numerator and denominator by the set 2, so you will get the answer to be set 2 over 4. Yeah, so make sure the answer has to be given in set form because that is what required in the question. Okay, you cannot give the answer in decimal unless it is not stated in the question. Then you do have the options. Okay, and then second, for the B part, the question says find the median. Okay, so in order to find median for this question, so it's about finding cumulative probability. Okay, so again, median, by definition, median is a value which divides the area into half. Okay, so median is a value which divides the area into half. So this is the, okay, the mathematical representation of finding median. So we know that the cumulative probability, okay, of median is equal to 0.5. So what do we do? Okay, so because we know that median will be located between 0 and 1, okay, so now we just integrate the PDF. So this is the integral of PDF. So 3 over 2 multiplied by set x. Okay, so from 0 to m, so we just equate this to half, yeah, because this is how to find the median basically. Okay, then we just integrate the function. Okay, and then we substitute the limits m and 0. Okay, and then we get half, and then okay, so we just simplifying and get the value of m. So okay, because it's not stated in the question, okay, so we can just give the m in decimal. Okay, so actually if you press calculator, the value of m is this 0.62996. But if you want to give the answer correct to 3 significant figures, okay, so the value would be m equals 0.630. All right. Okay, then the question says find expected value of x. So we know that expected value of x is also known as mean or expectation of x. So this is the formula. In order to find expectation is by integrating x multiplied by its PDF. Okay, so now x is coming from the formula. Okay, so you can see here x is coming from the formula, while this is coming from the PDF, yeah. And the constant 3/2, we just take it out. Okay, so to ease our integration, yeah, to make it easier for us to integrate. So my advice is, if you have any scalar, you bring the scalar out. So now we perform the product first, yeah. You perform the product before you can start integrating the function. So you can see here, x multiplied by x power half is simply x power of 3/2. Okay, so then only we can integrate. So you can see that integrating x power of 3/2 will give us, okay, integrating x power of 3/2 will give us x power of 5/2 divided by 5/2 is equivalent to multiply 2/5. Okay, and if you notice here, the 2 can be cancelled out. So 5, we take it out. So it will be 3/5. And then we substitute limit 1 into this function. So 1 power of 5/2 is 1. And then 0, we substitute into this. So 0 power of 5/2 is simply 0. And then you will get the answer as 3/5. Okay, so this is how to solve. Okay, so and again, I need to remind you, for this continuous random variable, we'll be dealing with integration quite a lot. So when we talk about your integration technique, it has to be perfect. You need to know how to integrate. We need to have the skills, yeah, the integration skills, and then only you can score this paper. Okay, if you don't know how to integrate, so make sure you revise, okay, all the basic rules of integration. Okay, so this is question number 2. Okay, now let's continue to next question. Okay, so let's see passing question number 3. Okay, so it's about continuous random variable as well. Okay, so we are given, yeah. So the question says the probability density function of a continuous random variable x is given. So we are given the PDF. Okay, so how do we solve this question? Okay, so first the question says find the value of k. So how to find the value of k? Okay, so first, as I said before, okay, first thing first, when you come across any topic 9 question in exam, okay, you identify whether the variable is discrete or continuous. So if it's discrete, so please come up with a table, please construct table, and if it's continuous, please draw number line. Okay, because if you draw number line, then you can see clearly which function exists for which region. Okay, so now you can see that, yeah, from the question given, so the function kx squared is defined from, okay, -1 to 2. So you can see here from -1 to 2, so we have function kx squared. And then next, okay, from 2 to 4, the function defined as k. So from 2 to 4, the function defined here as k. And then what does it mean by 0 otherwise? So 0 otherwise means throughout the number line, okay, except for these two regions, the functions are going to be 0. So you can see here for the rest of the regions, okay, except for the ones stated in the question, so the functions are going to be zeros, yeah. So which means the probabilities are all zeros. Okay, so the question says find the value of k. So because this is continuous, yeah, so this is continuous random variable, so we always begin with this, okay, because we know total area below the graph must be 1, yeah? So this is total area. Okay, so total area below the function, yeah, below PDF, okay, is 1. Okay, and then, okay, we can start integrating. And because we see that, okay, for this particular function, there are two functions defined, right? There are two different functions defined. So you can see that, okay, we are going to have two different integrals. Okay, because the function kx square here is defined. Okay, the function kx square here is defined. Okay, from -1 to 2. So you're going to integrate the function x square, kx square here from -1 to 2. And then for the second function, okay, from 2 to 4. Okay, so you can see here from 2 to 4, the function defined is k. And because k is a scalar, so we can just take it out. Alright, so now you just integrate and you equate to 1. Why? Because again, okay, we know that total area is 1. And then we just proceed with our integration. And this is very basic functions. Okay, the function here quadratic and also constant. So you integrate x square will give you x cubed over 3. And then integrating 1 with respect to x will give you x. Okay, then substituting limits. And then eventually you will get 5k equals 1, and then k equals 1/5. Okay, this question is not approving. Okay, so because it's not approving, so that means the answer will not be provided, no? Okay, in the question paper. So you need to be very careful when it comes to a value which you don't know the answer. So please make sure, okay, you try to solve it very carefully and try to get the correct answer. Why? Once you get the wrong value of k here, it will affect the rest of the solutions, yeah, throughout the, okay, the working solution, okay, for the B, C, and so on. Okay, so we have got the value of k, so we substitute back. So you can see that this is my number line, so I substitute back the value of k into the function. So you can see that this is 1 over 5 x squared and this is 1 over 5. Okay, so then second question, okay, find the cumulative distribution function. Okay, so this is going to be long. Okay, after we obtain our k value, we substitute into the PDF. Okay, so remember the cumulative distribution function. So the CDF is represented by the capital letter F, and the formula is this. Okay, so it's cumulative of, okay, probability from negative x until x, okay, of fx. So we need to integrate the PDF in this case. Okay, so we need to integrate the PDF. So, and from negative infinity until x. So this is general formula of CDF, of continuous random variable. So now, okay, what do we do first? Okay, we draw the number line and we substitute the value of k. So you can see that in this number line, there are 4 different regions involved, right? There are 4 different regions. So this is the first region, second region, third region, and fourth region. Okay, how are we going to obtain our CDF? So now, okay, first thing first, okay, we start with the first region. Okay, so for the first region here, okay, we begin with the first region and we put the x here. Okay, so that means for the first region, so you can see here, okay, I copy down the interval x less equal negative 1, and the PDF is going to, the CDF, okay, the CDF here is going to be this. So this is the formula. So this one is simply the formula. Okay, so it's from negative infinity to x. Okay, but yeah, if we are talking about the first region, so we put the x here, right? Okay, the x is here in the first region. So you can see that the function here is 0. So it's about integrating negative infinity to x, okay, the 0 function, and you can see, okay, the first value is 0, or the first function is 0. Okay, because it does make sense. Okay, CDF will always begin with 0 and end with 1. Okay, and then for the second region, okay, so for the second region here, okay, we're going to put the x here in the second region, yeah. So here you can see this is the second region, and I write down the respective interval, okay, and then this is the formula as well. Okay, so I just write down the formula. Okay, so this is, I write down formula here for the purpose of teaching and learning. But if you don't want to write down this formula in exam, it's not a big deal, as long as you provide the integrals here. Okay, so okay, when we put the x here, so you will notice that from negative infinity to reach our x here, it's going to be cross. Okay, it's going to cross 2 different functions, right? Okay, so this is the first function is going to cross, and this is the second function. So you can see that we are going to have 2 integrals. Okay, the first integral is from negative infinity until negative 1, and we integrate the function 0. And next, we're going to integrate from negative 1 to x. Okay, the function here, 1 over 5 x squared. Okay, and then this, the first integral here will give you 0, so you just write down 0. And for the second integral, you integrate here. Okay, you integrate x squared, you will get x cubed over 3. And then you bring the limits down, yeah? So you bring the limits down, negative 1 and x. Okay, and then next we substitute the limits, okay, the upper and lower limits. All right, and yeah, we are going to obtain a function. It's not going to be a value, because why? Because this is variable. So okay, once you have the upper limit to be variable, so it's going to be a function, okay, because variable here is going to give you a function, yeah. Okay, why? Because okay, we are looking for actually a function, right? We're not looking for a value. So that is why here you can see we have this CDF. So this is the CDF, okay, for this particular region. And next we continue with the third region. So coming back to this, okay, so continue with the third region. So which means here we are going to put our x in the third region. So you can see clearly, okay, in order for us, okay, to integrate, from negative infinity until x is going to cross three different functions. So this is the first function, second, and third function. So you can see that we are going to have three integrals in this case. Yeah. So okay, again, in order to integrate from negative infinity until x, we are going to cross three different functions, which are the 0, 1 over 5x squared, and 1 over 5. Okay, so that's why we do have three different integrals here. Okay, and then, okay, if you don't want to integrate this, okay, because we have done it before, right? So what you do is, okay, because you see the upper limit here is 2, so it's just about substituting the value of 2 into this function. Okay, this is actually obtaining the f2. So I would say this is basically obtaining the f2, yeah? So this is, the whole thing here is basically your f2. Okay? Yeah, okay, so then next you do this one. So integrating the constant function will give you x. Okay, and then substituting the upper limit here, x, and lower limit 2. So this is what you will get. Okay, and then based on this, okay, you substitute the value of 2 here, you will get 9 over 15. And then you simplify. Okay, so 9 over 15 minus 2 over 5 here will give you, okay, this function in simplified version. Yeah, so you will have 1 over 5 times x plus 1. So this is for the third region. And then for the last region, we know that it's going to be 1, because we know that CDF will always begin with 0 and end with 1. And in order, okay, for us to integrate from negative infinity to x, so we are going to cross four different functions, right? First, we're going to cross the 0, and then 1 over 5x squared, and then 1 over 5, and lastly the 0 function. And you know the total is going to be 1. Okay, so this is the final value of the cumulative distribution function. And again, because the question asks us to find function, right? So it has to be in piecewise. Okay, so it has to be in piecewise function. So writing down the function in piecewise. So make sure for CDF, so this is CDF, right? CDF will always begin with 0, and okay, it will always end with 1. Okay, make sure you take note this one. Okay, we had discussed this for discrete as well. So CDF for both discrete and continuous will always begin with 0 and end with 1. Okay, and then you just copy down the respective functions and the respective regions. This one also the respective function and the respective region. So this is your answer. Okay, so this is basically the CDF, cumulative distribution function for x. Okay, we are done with this. Next, okay, we continue with the C part, calculate. Okay, calculate the variance. Okay, for one Roman, we are required to find the variance. But again, we know the variance, okay, coming from this formula. Okay, so we cannot find the variance straightforward. Yeah. So what do? Okay, we need to apply this formula. So variance is basically expectation of x squared minus expectation of x squared. So in order to find the variance, we just need to find the expectation of x and expectation of x squared. So you can see here, expectation of x is simply integral of x multiplied its PDF. Okay, so now because we have obtained our PDF, okay, so the PDF is given in the question. So we just bring down the PDF. So please take note. So this is the PDF. So this is basically coming from the PDF, while this x is coming from the formula, because expectation of x is simply x multiplied by its PDF. So this one also, okay, because the second function is constant. So the x here is coming from the formula. Okay, and then we just integrate. Okay, so integrating x cubed will give you x power 4 over 4. Okay, make sure you expand this one first, before you integrate. X multiplied by x squared will give you x cubed, and then integrating x cubed will give you, okay, x power 4 over 4. And then this one, because this is simply x, single x, so you just integrate x squared over 2, and then substituting limits will give you 39 over 20. And next, okay, we need to find expectation of x. Okay, so expectation of x squared. So the formula is integral of x squared multiplied by its PDF. Okay, so please take note here, the x squared here coming from the x squared in the formula, while this x squared is coming from the PDF. Yeah, so this is the PDF. Okay, while this one also, the x square here is coming from the formula x square, because our PDF is simply constant 1, so it's x square times 1, which is x square. And now, okay, next, don't forget to expand first, yeah. X square times x square is x power 4. Okay, x square times x square is x power 4. So integrating x power 4 will give you x power 5 over 5. And then here, integrating x squared will give you x cubed over 3. And then substituting limits and then pressing calculator, then you will get this answer. Okay, expectation of x squared is 379 over 75. Okay, and this, we cannot stop here because this is not the answer that is the question is asking for. The question is asking for variance of x. So in order to find the variance, okay, you need to apply this formula. So it's expectation of x squared minus expectation of x squared. So now substituting the value of ex squared here. Okay, and then we substitute the value of EX 39 over 20. So we have here, and don't forget to square it because that is coming from the formula. Okay, so now we will get the value to be, okay, this. And the answer can be given in fraction, okay, in the simplest form of fraction or in decimal, correct to 3 significant figures. Okay, so this is basically how to find variance. So are we good so far, guys? Very good, yeah? Okay, so now let's continue. Okay, then for the second Roman, the question is asking for this variance of 3x minus 2. Okay, so in order to find variance of 3x minus 2, so rather than finding the new variance using the formula, so we will apply the properties of variance. Okay, so by using properties of variance, so variance of 3x minus 2 is basically variance of 3x plus variance of negative 2. And then we know that variance of a constant is simply 0, right, from the property. So variance of A is simply 0. Okay, so now if you want to take the, and again based on the second property, so variance of ax is equal to a squared times variance of x. So the idea is, if you want to bring the 3 out, don't forget to square it. So it's going to be 9 variance x. Okay, so 9 variance x, since we have obtained the variance x earlier, so you can just use this value and you bring it down, and then you multiply by 9. So this is the answer. So this is how to obtain variance of 3x minus 2. Okay, and then lastly, for the third Roman, find probability of absolute of x greater than 1. Okay, so in this case, we are going to apply the definition of absolute now. Okay, because this is greater, so we are going to apply this definition, absolute of x greater than a. So this is going to be x greater than a union with x less than negative a. So how do we know it's union? Because we use the go definition, yeah, greater or. But if you have absolute of x less than a, so it's going to be x less than a intersection with x greater than negative a. Okay, so this is law. Okay, so this is greater or, and this is less n. Okay, so now because we do have absolute of x greater than 1, so we are going to use the go definition, greater or. So x greater than 1 or x less than negative 1. Okay, and yeah, by using the additional probability formula, so it's probability of x greater than 1 plus probability of x less than negative 1. And because the intersection is not going to happen, so okay, the intersection is 0. Okay, so now the union between these two events is just simply the addition of these two probabilities. And okay, because you see that, okay, for x less than negative 1, the function is 0, right? Okay, because when we draw number line just now, okay, when we draw the respective number line, the PDF is defined from negative 1 until 2, and then 2 to 4. Okay, so the PDF here is defined like this. Okay, so this is 1 over 5 x square, and this one, the second one is, okay, 1 over 5 only. So you can see that, okay, for this particular value, probability of x less than negative 1, you can see that the function here is going to be 0, right? So we can say that this value is going to be 0. So, okay, there's no value to this. Okay, so that means the probability of x less than -1 is 0. So we just focus on finding this only, probability of x greater than 1. So you can see that 1 is between -1 and 2, right? So 1 is located here. When x is greater than 1, it will cross two different function here. This is the first one and this is the second one. So what we're going to do, first we're going to integrate from 1 to 2 and then plus with 2 to 4. Okay, and we integrate the respective functions and then substituting limits. Okay, and then we will get the value. Or, okay, so this is the solution using PDF. Okay, this is the probability distribution function. While if, yeah, because since we already have the cumulative distribution function, right? So we can just make full use of it. So again, okay, in order to find probability of absolute of x greater than 1, so it's by using the definition. And again, we know that this is going to be 0, okay, because there's no function, of the function of x less than -1 is 0. So we know that, okay, there is no area, okay, no area below the graph. Okay, the area is going to be 0, and we just need to focus on finding this, okay, probability of x greater than 1. Okay, so but because we have cumulative function, okay, the cumulative function is this, is probability of x less equal x. Okay, which means from x going to the left. So now, okay, by drawing number line, okay, we want this x greater than 1. We want this. Okay, but we don't want this. Okay, we don't want x less than 1. And but because cumulative, we always have this sign, right, less than. So what do we do? It's 1 minus, yeah, to in order to find probability of x. Okay, probability of x greater than 1. So it's 1 minus probability of x less equal 1. Okay, because this is the region that we want and this is the region that we don't want. Okay, so this is the region that we want and this is the region that we don't want. So the region that we don't want, we're going to subtract, yeah. So the whole thing, okay, the total area, which is 1 minus with the one that we don't want, so we will have, okay, this region. So in this case, okay, so it will have, okay, we will have 1 minus f1, and then we just substitute the 1 into the cumulative function just now. Okay, so let's recall the cumulative function. Okay, so this is the cumulative function, right? Okay, so this is the cumulative function that we have. And you see that 1 is located here. So 1 is located here. 1 is inside here. So what we're going to do in order to find f1, we substitute the value of 1 into this second function of CDF. Okay, so substituting 1 into this, so you will have 1 over 5 times 1 cube plus 1. So it's going to be 13 over 15. So exactly the same answer, even though we use two different methods. Okay, so I hope this is clear enough for you to understand the concept. So actually you can find probability using either PDF or you can also use the CDF if we do have. Alright, so because in this question we already have both, so we can either use, okay, one of these methods. Okay, so now let's continue, okay, to the next question. So we are done with passing question number 3. Now we discuss passing question number 5. Okay, so passing question number 5 is stated that the time taken by a student in hours to study is given by a continuous variable x with a cumulative density function. Okay, so in this question, we are given the CDF. Okay, compared to the previous two, we were given the PDF. So now, okay, we are given the CDF. So please bear in mind, so this is the CDF. CDF of continuous random variable. Okay, so where k is a constant, so now determine the value of k. So how can we find the value of k? So because we know that this is cumulative distribution function and the cumulative, okay, so okay, let's draw a number line. If we draw a number line, so this is 0. So when x is less than 0, the formula, okay, the function is 0. And when x is between 0 and 10, okay, so the function is defined as this, 1 minus k. So the function is 1 minus k times 10 minus x squared. And then when x is greater than 10, so the function is 1. So this is the CDF. Okay, so you will notice that, okay, for this particular value of x, okay, for this particular value of x, okay, so for this particular value of x, there are two functions defined. First, the function, when we substitute 0 here, so this is f0, and when we substitute the value of 0 into this function, we will have f0 as well. Okay, so we can equate the two. When we substitute the 0 into both functions, we can equate, okay, because the values are going to be the same. So what do we do? So f0 is equal to, okay, by substituting 0 into the second function here, so we will have 1 minus k times 10 minus 0 squared, and then we equate to this, so which is 0. Okay, and then you just expand and writing down the k as a subject, so k is 1 over 100. Okay, so this k is going to be 1 over 100, yeah. Okay, then next question, find the probability. Okay, so because we are given the CDF, so in this case, we will not be looking for the probability using PDF. Yeah, because we don't have, at the moment, we don't have the PDF. Okay, so we don't have to find it yet, okay, until we reach this question. Okay, we can only find the PDF in the C question. So for the B part, okay, in order to find the probability here, we just make full use of the CDF that we already have. Okay, so this is the CDF that we have, okay, with the K value 1 over 100. So in order to obtain the probabilities, okay, of x greater equal 3, less than 9, so the formula is going to be F9 minus F3. Okay, we had discussed before, right? For continuous random variable, the equal sign does not matter. Okay, so even though we have equal or not here, it's simply, okay, it's simply F9 minus F3. Okay, so now what do? We substitute the value of 9, okay, into this function, and then we substitute also the value of 3 into the same function. Why? Because we can see that, okay, the 3 and 9 are both located in this region. Yeah, so 3 is here, 9 is also here. So that's why we can substitute both values of 3 and 9 into the same function here. Okay, so substituting the value of 9 and then the value of 3, so you will see that the probability is going to be 12 over 25. Okay, and then next, only we are required to find the PDF. So in order to find the PDF, so we discussed just now, so from PDF to CDF, okay, which is the capital F, so this is the PDF. Okay, if you want to find PDF, okay, if you want to find CDF from PDF, you're going to integrate, right? Okay, but now because we are provided with CDF, and in order to find the PDF, we just need to differentiate. Okay, so this is the one that we need to, okay, perform. So we are going to perform differentiation. Okay, so we just take each and every region. Okay, so for the first region, okay, we find the derivative 0, and for the second region, we find the derivative, which is this function. And then, okay, for the third region, okay, we find the derivative. Okay, we find the derivative. So the derivative of the constant is simply 0. Okay, next, because we are looking for PDF, so the function is, okay, the function has to be given in piecewise. Yeah, again, I need to remind you, whenever you are required to find function, make sure it's in piecewise. So this is the answer. Okay, then next, the question says, for the D part, find the median. So in order to find median, there are two different ways. Okay, why? Because, okay, we already have both CDF and PDF, right? Okay, so please bear in mind, median is what? Median is a value which divides the area into halves. Okay, so median is the value which divides the area into half. So since we do have the CDF, so you can use the CDF to find the median, or since we also have the PDF, yeah, that we have found earlier in the C part, so this is how we can find the median using PDF. Okay, so you can see that, okay, for the first method here, this one, I find the median using CDF. So this one using CDF. While for the second method here, okay, so you can see that this one is the method of, okay, finding median using PDF. Okay, so I would say the easier one is to use the CDF, because, okay, if you want to use CDF, you just substitute the M into the CDF and you equate to half. And then, okay, finding the value of M, because this is quadratic, you have two values. Okay, and because we know the median is located between 0 and 10, right? Okay, so between 0 and 10, so we are going to accept only one value. Okay, so this value here is going to be rejected. Why? Because it falls outside the range. And if you want to use the PDF, so we find the area. So finding the area is by integrating the PDF, yeah. So please take note, this is the PDF, okay, that we have obtained earlier. Okay, so you integrate the PDF and then you equate the area to half, and then you integrate the function using the rules of integration, and then substituting limits and okay, solving the quadratic. Okay, then you will notice that you will have okay two values, and again because m is between 0 to 10, so your answer that you're going to accept is 2.92. Okay, so either method that you apply, okay, you will get exactly the same answer. Okay, and I would say that the first method is easier. Okay, because you don't have to integrate anymore. You just substitute the value the m into the function and then try to find the m. Okay, so that is the fourth okay part of the question. Find the median, and next E, find the variance. Okay, so again, in order to find variance, okay, so you need to find the expectation and the expectation of x square. So substituting, okay, this is the formula. So this case you see this is the x multiplied by its PDF. So this is coming from the PDF while this is coming from the formula. And then don't forget to expand first. Okay, make sure you expand first before you start integrating. Yeah, expand first. Okay, then you integrate and then you substitute limits, so you will get this value. And next, okay, find the expectation of x squared. So we do the same thing also. So please bear in mind, this is the formula. So x squared here is coming from the formula, while this one is coming from the PDF. Okay, we bring it down. So this is the formula of expectation of x squared. Okay, so then make sure you expand first. This one expand, expand these two first. Okay, expand first before you start integrating. Okay, so then after you integrate, substitute limits, then you will get this value. And then lastly, finding the variance is just about substituting into the formula. Yeah? Okay, so expectation of x squared you obtain is 50 over 3. And then expectation of x is 10 over 3, okay, from the previous year. Okay, so you can see that this is 10 over 3, and don't forget to square it because that is actually coming from the formula. So you will see that the answer is 50 over 9. Okay. Yeah, so this is how to solve past year question number 2, 3 and 5. Okay, so I hope that this will ease your burdens a bit. If not all your burdens, so at least this can ease your burden a bit. Okay, and yeah, it's now 5 minutes to 11, so I don't think that we will be able to discuss the next question, but yeah, I'm going to give you the solution in the Google Classroom. Okay, so exactly the same method. Okay, so this is past year question 14-15, where you are given the CDF. Okay, so you can find here all the methods needed to solve the problems. Okay, so finding the probabilities. Okay, so this one I just scroll, okay, the solution at a glance, then finding median using CDF, okay, because we are only provided with the CDF in the question, and then determine the PDF. So it's just by okay differentiating the CDF. So you can see here there are 8 marks allocated, and then hence evaluate the expectation. So okay, find the expectation of x squared is by using the formula. Then you expand first these two, then only you integrate, substitute limit. So this is expectation. Okay, and then substituting the value. So this is the answer. Okay, so this is basically how to solve continuous. So again, for continuous random variable, we'll be dealing with integration a lot. So make sure guys, you know how to integrate and do it very well. Okay, then only you can answer this question correctly. Okay, so it's now 5 minutes to 11 o'clock. So I think that's all for today, guys. Okay, so happy fasting to my Muslim students, and for the rest, okay, take care. Okay, so thank you for your attention and your presence. Okay, so I will end this lecture today with Assalamualaikum warahmatullahi wabarakatuh, and have a nice day, everyone. Bye bye. My pleasure.